whenever the point xy is on the graph, and so is x comma negative y. Now, if it's symmetric across the x-axis, it's actually not a function at all. Because if you remember the vertical line test, you'll see that it fails every time. Okay, so let's say, for example, let's say if you have the graph that looks like this, kind of like a sideways bell. Okay, and let's say here x is equal to 1. When you plug in 1, let's say you get 4 here. But you get negative 4 here. Okay. And again, if you see you fail the vertical line test, so you know it's not a function. But it is symmetric across the x-axis. Okay. So for any value of x that you can pick, let's say you could keep on going all the way down the line till you reach some value of x. You'll have some x comma y and x comma negative y. Okay. So of course, the test to see if it's symmetric across the x-axis, you're going to replace y with negative y. Okay, so to test, see if a function is symmetric across, I can't even really call it a function, say if a graph. Because once it fails the horizontal line test, it's not a function anymore. Oh, there we go. Across the x-axis. 1, replace y with negative y. Two, you get the same expression, because we can't call it a function now. Then the graph is symmetric across the x-axis. Okay. Now, it is possible that you could try all 3 tests and the graph that you're testing doesn't fall under any of them. So then it'll just be if it's odd or even, you have the odd, is it even, or is it neither? So sometimes it'll fall under the neither category. All right. I'm still writing. All right, so let's say, for example, are the following, can't call them functions, so graph symmetric across the x-axis. Let's say for problem A, say x equals y squared plus 1. Let's say for b, x equals y to the 4th plus 2y squared plus, I'll leave it at that. Y to the 4th plus 2y squared. Okay. So if we want to check to see if it's symmetrical across the x-axis, we just have to replace y with negative y. Okay, so for problem A, you have x equals y squared plus 1. Okay, so you have x equals negative y squared plus 1. Negative y times negative y is just positive y squared. So you have x equals y squared plus 1. Okay, so you know this is symmetrical across the x-axis. All right, so say for B, x equals y to the 4th plus 2y squared. And hopefully you kind of see the pattern with this one, because if you notice, all the exponents for the y values are even. So whenever you plug in a negative y, if that exponent is even, it'll always go back to being a positive y. So if you ever get one that has like y to the 3rd, then you automatically know it's not going to be the same, because you're going to come out with a negative y. Okay, so here you have x equals negative y to the 4th plus 2 times negative y squared. So that gives you x equals negative y times negative y, or 4 times, come up with positive y to the 4th. Plus 2 negative y times negative y is y squared. So you end up right back where you started. So it's symmetrical across the y-axis, x-axis. Sorry about that. All right. So any questions on that one? All right. Let's do, give it a few more seconds. All right. Did I put that in the wrong pile? Oh, that's the right one. Okay, so if you have, let's say, a graph like that, and they want to know whether it's odd or even, then you know it's even if it looks like a mirror image across the y-axis. Okay. Now you know it's odd if it looks like you flip it across the y-axis and then again over the x-axis. So if you notice here, if you flip this one around across that, it will look kind of like that. So now if you flip it across the y-axis and then flip it again this way, you'll see it matches there. So that's how you know this one is what? Yep, it's odd. Okay. So to find an odd graph, you'd have to flip it twice. Okay. Any questions on this one? All right. So let's say if you have this graph here. Okay, so if you held up a mirror right here, it would look just like that, like it's just a reflection across the y-axis. So you know this one is what? Even. Yep, even. All right, so same with this one here. That one is which one? Yep, it's odd. Because if you reflect it across the y-axis, you kind of get that. And then if you reflect it back that way, it matches. Yep, so this one's odd. And this one is what? Yep, this one falls under neither. Because it's not a reflection across the y-axis. It's if you get this side and flip it, it doesn't match up in any way, shape, or form. So this one actually would fall under the neither category. All right, so let's try last section here. Move those out the way. These are one-to-one functions. Uh-oh, got my pen. Move those over there. Yep, some more. Okay, so with one-to-one functions, if you remember, that if you just have a regular function, every x value has exactly one y value. Or your input has exactly one y value. Uh-oh, output. Okay, so let's say, for example, if you have, let's say, if you wanted to determine if the following are functions.